a linear function, or again a function, a polynomial of first order. Here we have x power 1. This is, why do we say here first order? If I take, for instance, f of x equals say 4 plus 6x, right? So this is x, not delta. Here we have a function. This is a function of first order. The highest degree here of x is 1. If I consider rather, I hope you are accepting everybody who wants to come admit. So if we consider, for instance, sorry. If I take, for instance, I hope you can hear me, please.
We can hear you.
Thank you so much. Always good to hear from someone replying. Thank you. I take, for instance, the function f of x equals, say, 3x power 2, right? Oh, sorry. Gosh, I don't know what's wrong with my mouse. Plus something, say, for instance, 4x. Of course, this is no longer a linear function, right? This is no longer a first order. Here I have a x power 2, right? For linearity, we must have x power 1. Now, just to avoid giving you guys theoretical problems here, let's consider, for instance, now in the first chapter, we discussed the issue, the problem of demand and supply, right? And we denoted by Q the number of items that the company is producing, right? And we assume that Q can be given as a function of the price. Q equals A. Okay, remind me again the formula or the model for the demand. For Q equals A plus B, right? Times P. Do you remember, please, that? And here we have, P is, of course, first order is P power 1. This is a linear function for the demand, right? And sometimes we also for the supply, also a linear function, A, sorry, we do need maybe C. For the supply, what was, again, the model? C minus D times P, right? So here, basically here, what we mean by is that the demand Q, or the quantity Q, is a linear function, or is a function, a function of P, of the price, right? In other words, if the price varies, Q also will vary. The quantity will vary. The quantity depends on the price P, right? And this is a linear function, basically. Linear, basically, here we mean by first order, a linear function. The highest exponent of P is 1, right? I repeat, if we had something like Q equals, say, for instance, 2. Yeah. If we write, for instance, P equals 4 plus 3. P squared, right? Can you all see my whiteboard, please? If we have this function here, this is no longer a linear function because here P has exponent 2, power 2, right? P second power, right? This is no longer linear. It's no longer first order or first degree. This is a second, a second order polynomial. Then that is no longer a linear function. We'll come back to that after, right? Now, what did we do then with the linear functions? I repeat, linear functions up to so far. These are like the most basic functions, linear functions. Linear from the word line, right? And you given a plot. If you plot Q as a function of P, you have something like this. If this is P, the price, this is Q, right? Then we have the function is a linear function. In other words, if you have 2 points, two values of P, you can deduce exactly everything else because the line will pass by those 2 points once for all. Linear functions. Excellent. Now, what did we do so far with the linear functions? We discussed the issue of revenue, costs, and profit, right? You remember how to compute the cost and the profit and the revenue, demand and supply. We also assume that these two functions are linear functions. We discussed the issue of price elasticity of demand and supply, and we'll come back to that. We'll come back to those concepts in exercises very soon. Now, applications, we also discussed the issue of equilibrium, right? Here, the problem of equilibrium is only to solve remember here we have the quantity demanded, right? Must be equal to the quantity supplied, right? Please do you remember this, please? For those who were there last time. No one is. Also, the price. The price demand must also be the same as the price for the supply, right? And when you solve these two equations, you obtain what we call equilibrium point, the Q and P, right? And P. When you solve this system, you must be able then to solve. It's important then to be able to solve a system of two linear equations, right? Linear equation. Right. Can you please mute, please? Now, we'll come back to the issue of consumer and producer supply. Surplus that we'll do next time. But I want first to look at the non-linear. I'll skip first the concept of
No.
I don't know what's wrong with it.
Hello? You lose our lecturer. Yeah,
It looks like
good.
it. Looks like it.
Okay, cool.
Oh, yeah. I think it's maybe in the other.
Hi guys, what page are we on?
Chapter 3.
The professor's left. Oh, he's trying to come back.
Yeah, I'm sure there's a technical error. He will fix it soon. He will be back online.
How was your guys' day?
Pretty long. How was yours?
Yeah, long.
Yeah,
Please tell
really
me,
long.
does anybody have the previous recordings for the other sessions? Or do you know where we
No.
can find them?
Yeah, please
Oh.
share that.
He was busy presenting and then he fell away. The screen fell away.
No,
And
no, so all
then-
the previous lessons.
The previous lessons, yeah, I also looked for it. I couldn't find it, but he did say that he recorded it, so, or someone recorded it.
Okay.
I've seen one on additional resources somewhere there on the,
Is
Yeah,
it-
but it's empty.
or is it empty?
you
I just
Yeah.
saw
If
it.
you
I've never went
go,
into it.
if you go under announcements, apparently it's there somewhere.
Yeah, under
Okay.
announcements, and then it's got online videos and short videos. Those folders
Yeah,
are empty. I don't know on mine.
Oh, is it empty? Oh. And is there any way to text, like you know, the other classes normally have a place where you can speak on the side. There isn't one this time.
Yeah, I see
Even
that.
last week they were complaining about it, that they don't have an option to type. So I
Yeah.
wonder why.
So because
Announcement.
last week we had about
I think
100 people and we only have
we do
30,
have
so I'm
access to
worried
chat.
that he's gone somewhere else.
We do
to
have
another
access
link.
to chat today. I see it's active. I've sent him
Where?
a request to join on top. Do you want me to share my screen? Let me show you.
I don't have the chat option.
Neither do I.
Is that Portia?
Yes, can you see there is people and then there's chat. there.
Oh, for some
no,
reason I don't have the chat option.
I
Yeah,
don't
neither
have the
do I.
chat option either.
Can you see my
No,
screen?
Yeah.
Yeah, we can.
Yeah, there's people. I sent him a request to join, but I'm not seeing him accepting it. His name is what is the name again?
is Sakero? Professor
Mukeru
Isn't
Safari.
it Safari?
Mugeri Safari. Yeah.
Yes.
There is a request to. I sent him a request to join.
Because remember last week there were two links. There was a group of people on the other side. Now I don't know what link I'm on.
Oh, goodness me. I hope it's not the same thing.
No, that link is not working today.
Oh, okay. Well, that's good news.
Yeah, maybe he's having some technical issues. I'm sure he'll be back soon.
Portia, how do you have that link? I mean, how do you have the chat option now? I also want that.
I
Yeah.
don't know. I just found it now. All of a sudden, also on my side appearing. So
And then you're also
with the
able to
previous
share the
classes, it was not there.
screen. You're also able to share your screen. I don't think that's an option that we all have.
Yeah.
I
I
also
don't
have that
I
option
also
to
have
share the
to share.
screen. It's just the chats that I don't have.
And I think that's the problem. We must ask him to give us all of us access, because that's where you're gonna find the the video, the recording afterwards.
Yeah, well, I can laugh. Did you see me laugh now? Yeah.
Yeah.
I'm on the My UNISA website, and there isn't any of the previous videos. Does anybody have it on Teams that you could share?
Last week one, I didn't see it. I don't think it was recorded because we were on the other side. The Monday one, we were on the other side. We only joined late because there was another class that was open.
So normally when
and-
you join a Teams meeting and the session is recorded, it auto saves on your desktop but with this one, I don't know what happens. I was on the first lesson and second, and it didn't save.
But it's weird because I always get the message on top that said that this session is being recorded.
Yeah, I don't
Yes,
think
let's
this
make
one
sure
is
that he
being
gets
recorded.
paid, that he does his job. It's not for us. Well, not as yet.
Yeah.
Hi.
Well, there's nothing recording at the moment besides us talking, so.
I'll share again.
And
I see-
listen,
let me show
there
you
is a
mine
together
one.
mode. Sorry,
Hello.
yeah.
Can
Yes.
you see the previous one on the 10th of August? Here's the recording.
Oh.
And then that was the first one. Let me go out.
Yes, you got nice life problems, huh?
Portia, is there any way you can share that with us?
Yeah, because
let me
I
see.
also don't have it.
Copy the link. Let me see if it will be able to
Yeah,
copy.
just paste it there in the conversation. Hopefully I pop up on the conversation too.
Copy,
Yeah.
yeah. Let me
I
paste it
see
here.
a whole pile of exasperated faces. Or
Yeah,
they're
I
so
just shared
excited.
it on the
Oh, hearts.
conversation. I've reshared. This is the meeting that happened on the 10th. Then this one, it happened when, let me see. I'm not, because I haven't gone through this one. I'm not sure if it's the right one that, you remember there was the time we were in another meeting and then he was on another meeting.
Yes, that was the first one.
That was
And
the
then he
first
got
one.
sick for the second one, yeah. And now we're having
So,
the third
If you
one.
share
okay.
on this chat, those of us that don't have the chat option are not going to see it.
Yeah.
Yeah, because I also don't have the chat option.
I'm sorry, I'm back now. I don't know what happened with my connection. I'm so sorry, guys. Please forgive me. This is not beyond my ability. I'm sorry. I'm back now. You are still there.
Yes. Can we ask you one question, please?
Yes,
How
please.
do we access all of the previous recordings as well as the current one, which I think you need to record this one again.
Yes,
and how do we
okay.
access all of the recordings, because it's nowhere online?
Let me record this one first. Here I see recordings has started, right? It should be already recording. It should be on the charts. But I will ask my colleague Nolowazi to help to find out where they are and make them available to everybody.
Yeah, even if you could put it on the My UNISA site, that would be great, because a couple of us have asked on the chats on My UNISA and nothing's been loaded yet, please.
We'll try. I'll ask her to do so, please.
Thank you.
Here they say is recorded, right? Is recording, right? So it should be somewhere, right? Maybe we can record also. Let me see if I can record again, please. Sorry again
I
for
think,
the.
Prof,
Yes, please.
I think maybe if the person who scheduled the meeting can give everybody access to chats, I think that's the major problem where most people can't find the recording because they don't have access to chat.
How do you give everybody? I mean, why you don't have even access to the chat? I asked it to help me with this, but they didn't help me at all. I don't know.
I do have access, but others don't have.
Now, can you give them? Can you give them access, please? Very funny.
The one it will be set with the one who set up the meeting.
Okay, where do I go to do that? How do I proceed to give access? Because I'm the one who started the meeting.
Okay, go to more.
More, huh?
And then what options are there? Device settings or anything?
Call health, meeting options, meeting in notes, meeting info, and so on.
Meeting options.
Meeting options, yes.
Can you share your screen? Let's see.
Okay, let me share. Where is it now? I don't even know which one to share now. Where am I? Okay, maybe. Okay, I see. I say, who can bypass the lobby? What can I? Who can bypass? What can I say there? Always let bypass.
Yeah, everyone.
Everyone. Okay. Who can bypass? Let me see. Everyone. Okay. Great. What else?
Is it showing messages or chat?
Let me see
And maybe
that.
maybe if you can display your screen so that you can see what you see.
Okay. What I see. I don't have a problem with that. Please, if I Windows, I don't even know which one to click on here now. There, I see. No, I think it's not here. I don't know which. Can you maybe if it's continue with the class? Maybe we can do that when we finish, right? To save time.
No problem.
General channels.
Please. Let me first. We'll come back to this point.
Microsoft Teams.
Yes. Can you see what is there now? Who can present? Everyone can present. Yes. Allow mic to attendees. Record automatically. Yes. Right. Allow reactions. No problem. Enable a Q&A. What else? Q&A. Yes.
Yeah, Q&A. Then they can load the link.
Okay.
Osha, please.
Okay. I did that. Done.
Ah.
Are you sure that will be enough?
Now they can copy that link here in the chat.
Okay, great. Right, let me go back to the class. Actually, today I want to do some to jump to differentiation, but before that.
Yes, please. Okay.
Yes, okay. We will go back to the previous chapter because I want to cover differentiation and integration as soon as possible. But let's go to differentiation. Maybe we'll come back to the previous section. There are maybe next week or so. Great. Okay. I don't want to follow a linear model here, but let me just jump to differentiation. Is it far from? I don't think so. Great. Please, anything that we skip, I promise we'll come back to that, either in exercises or find out how to give also the basics for those. But everything there is quite some linear models that can be easily understood. We'll come back to that. Sorry. Great. Okay. Yes. Yes. Welcome. Okay. Great. Nothing to hide. Now, here I'm on page 57 of the study guide. If you have the study guide with you, feel free to go to page 57.
Sorry, what page?
57.
57. Or we'll come back to the chapter that we used. Great. Now, let me take a function. Let me consider a function. Right? Sorry. Consider a function f of x.
I'm sorry, I still see the meeting screen. Is it just me?
Let me share the maybe
Also don't see it.
Okay, I'll share again the whiteboard, please. No problem. Can you now see something different?
Okay.
Okay, good. Okay, good.
Yes, we're good.
Okay. consider the following function: 3x. Let me take 3x plus 4.
Which page are we on here?
I am on page 50 something, 58, 50. You can even follow on the. You can just follow on
57.
the. You can just follow on the board. I think it will be enough. Right. Right. Now, here the issue of differentiation, as you'll see very soon, is the issue of the marginal change. How do here we have a function of x, right? F of x equals 3x plus 4. If I ask you to find what is f of 1 here? What is f of 1? What is f of 1, please? Who can answer the question?
6.
F of 1 is equal to
1.
no, 3 is 3. Look here. F of
Or
x is
if
3x plus
7.
3 times 1, what is 7? 3 times 1 plus 4, right? Please, can you put the mute unless you want to talk, please? Can you mute the mic unless you want to? Great, okay. So this is 7, right? Now, if I consider another point, f of 2, what is f of 2? Basically, here the meaning is you replace x by 2, right? It will be 3 times 2 plus 4, right? And this is equal to 10, right? F of 0. What is f of 0, please?
4.
4, yes. Sorry. F of 0 is 4. Very basic, very easy, very elementary. 4. Great. Now, this is a function. To every value x, we associate another number that is f of x, right? Called the image of x by the function f, right? And number, we associate another value, an image. So here when we write y equals f of x, so sometimes we can also write y equals f of x, and then we associate to every value x another number called f of x, or simply equals to y. Okay. Now, want to understand then, please, can you put a mute, please, the mic? Great. Now let's take the number x. Let's take f of 2. Let's take f of 2 plus a number we call h, right? Let's consider here this difference, please. F of x plus h. Consider any number h, and let us see what is difference equal to. F of 2 plus x, sorry, 2 plus h minus f of 2, and we divide by the difference h. Here I want to see then, how does a change in the value of x modify the change in terms of the function? How does a variation in the value of x right? How does a change in x influence a change in the value of the image of x? Great. Let's first, can you please help me to compute this value? What is f of 2 plus h? Here, assume h is any number. What is f of 2 plus h? What is f of x again? Please, anybody please to answer. What is f of x? I hope you can hear me. F of x is, in general, we say
it's not y.
Yes, y, but what is the value that we gave here? The value is here, right? The value is here, 3x plus 4, right? This is our example.
Oh, it's 3.
3x plus 4, right? This is our model. F of x is given by 3 times x plus 4. Right, now, if I have now to compute 3x plus 4. Great. Now, if then I have to compute f of 2 plus x, f of 2 plus h, what will I do? What can I do? How can I find that value? How can I compute f of 2 plus h? We simply replace x by 2 plus h, right? So this will be 3 multiplied by 2 plus h. Are you with me, please? Are you with me?
Yes, Prof.
Yes,
Following.
Prof.
Yes, plus 4, right? This is the value of f of 2 plus h, right? Now, minus, multiply like this. F of 2, what is f of 2? What is f of 2, please? Come on.
10.
10, yes. 3 times 2, right? We replace f of 2. Let me put here down so everybody can see where we are. This is simply 3 times 2. 3 times 2 plus 4. And this is equal to 10. Right. Great. Then here we have minus 10. And we divide by the value h itself, right? It's clear. Let me delete all of this. Now, who can now compute the difference? Then we can continue as follows. Sorry to delete what's slow. Yeah. Okay, good. Now we have the following. This difference is equal to. Now, if we now multiply, this will be 6, right? 3 times 2. 6 plus 3 times h is 3h, right? Clear, right? Plus 4. Minus 10. Divided by h. Right. If we continue the calculation, what do we obtain?
3h over h.
Yes, 3h over h. 3h over h. And if we simplify by h, or what we say, we take the limit when h goes to 0, we can simplify here h, sorry, right? And this gives us exactly the number 3, right? What does it mean then? What do we then have here? I say f of x, sorry, it was 2 plus h, any number 2 plus h minus f of 2, right, over divided by this quantity, which is basically like here, like we have 2 plus h. Why is she exit? Why is she leaving? Over h. The answer that we have here is equal to 3, right? So now here, when we have the change, this 3 here will we'll call this number the derivative of the function f at the point x equals 2. Before I give the definition, let me take another example. I have another function. Yes, please. Yes, please. Yes.
There was something somewhere where you say 3 of bracket 2 plus h plus 4 minus 10.
Yes, please. Yes.
Yes. I got to be there.
Multiply 3 by 2, right? Is 6. 3 by h, 3h, plus 4, right? Minus 10. No, 6 plus 4 is 10 minus 10 is 0. 3h over h. Right? Right?
Okay, sir.
We look at the following. We have here the function f. The function f of x was given by, what's it again? 3x, right? 3x plus 4. The mouse is very unstable today, right? Hope we improve. Great. Now, this is a linear function, as you can see. But my question is the following then. How do we understand? Here we want to understand how does x, how does f vary as a result of any variation in x? Right. If we have here the number 2, what is the image of 2 again? Is 10, right? We know that, right? Now, if we take a change around 2, like 2 plus h, this change here corresponds to another. Here we obtain the same thing, the value of 2 plus h by f, or the image of 2 plus h. We have that this is f of 2 plus h, and this is equal to f of 2 plus h, right? Now, if we take this, if we take it out here, the difference, between the two images, and the difference between the two values of x, right? And we take the difference. So here we have f of 2 plus h minus f of 2, right? We divide by the change into the value of a. Here we have 2 plus h, 2 plus h minus 2. This change, right? And we take the limit here. We take the limit when this number is very small, when the number h goes to 0. The quantity that we obtain, this answer is called the derivative of the function f at the point 2, and we do it by f prime of 2. The derivative of the function f at the value 2. Right. Let me maybe I can try to make to draw something maybe that you can see clearly what I'm saying. I will explain very, very clearly. I'm sure you will get it very clearly. Let me draw the following function. Now, in general, assume we have such a function. Always very difficult to draw with a mouse. It might get much better. Assume we have the following function out in general. Here I have the point x is there. You can see here I'm on page 59. 1. Here I have the point 2 here, somewhere there. Right. The function is growing according to this graph. Now, let's take the difference from this point to this one. This length here. Right? This is the image of f. This is f of 1. F of 1. Assume that this is 1. Let me take here the other point, f of 2. Oh my goodness! I hope you are with me. I will explain this concept. It's a very easy concept. Believe me. I will explain. F of 2 is there. Now take the difference. Now we take the line. We join this point and this one with a linear function, something like that. Right. Now, when we take the difference f of 2 minus f of 1 and we divide by the difference, 2 minus 1. Right? This gives us the rate of change in the interval from 1 to 2. Now, assume that instead of 2 here, assume that we have just not 2, but now if we take this now very small, say 1 plus h instead of 2. So this now will become f of 1 plus h. 1 plus h. Now we have the difference f of 1 plus h minus f of 1. The difference between the two images, you divide by the difference between the two initial points, 1 plus h minus 1, which is simply h. And when this point, when h, this difference h goes to 0, this limit is called the derivative of the function f at the point x equals 1. I'm sure very few understood even what I'm talking about so far. Let me take maybe another example to bring you back to what I'm saying. Let's take another function, please. F of x equals x squared. Let me take, for instance, x squared plus something. Plus what, for instance? Please give me an example of your choice. F of x equals x squared plus. And you want to give an example? So, for instance, plus 3. Please, are you there, please? At least, can you see my board, please? At least.
We can see your board, sir.
Okay, great. At least I know that you are there. Great. We want to define what we call the derivative of the function. The derivative of the function f at any point x. F prime of x. This is again denoted again by df, sometimes df divided over dx, just for the notation. But how do we define this quantity? The derivative of a function, right? You have a function, you want to define a new function from that first one called the derivative of the first function, right? How do we proceed to define that derivative? And this is very important in application. How do we then proceed, right? let's apply the definition. We'll see the formulas after, but for now, let's just try to understand the definition. The function f of x is given there. If I ask you what is the value of f of 0, what is the value of what is f of 0 here, please?
That not 3.
Yeah, 3. Yes, 3. Right. Any number you can find f of -1. What is f of -1?
Oh.
Yes, 4. -1 squared will be 1, right? -1 squared, -1 power 2 plus 3. We know -1 squared is 1. It should be 4, right? Now we want now to define. Here we have a function. Now we want to define a new function from f, right? That will be called the derivative of f. Now, this is how we define this function. F prime of x. Please listen. Please now follow the definition. F of x equals. Sorry, f prime of x equals. Let's see, you take. You add. You take f of x plus one number that you call h. I mean, it's like a difference or just a change in the value of x plus h. So instead of h, they put delta x or whatever is not a problem. Minus what? Please continue. Minus f of x please don't. I hope you are following. I'll go through that. We can all catch the definition. Divide by. We divide by what? By what number? By h. Yes, h. Yes, divide by h. And we take now with the limit. We take this number. We take the limit when h goes to 0. When the number is very, very small, right? Like the rate of change. This will be like the rate of change in the function divided by the rate of change. Sorry, the rate of change into the function. How does f vary when x varies? I mean, when x when we vary around x. F of x plus h minus f of x divided by h. Right, now what do we do then to compute this quantity? How do we proceed? What is now f of x plus h? We go back to the function f. Look here, the f here. This is f, right? This is our function f here. If ask you how do you find the f of x plus h, what do you do to find the value of any number? Anyone please to answer this question? What is f of x plus h? You simply replace. Look, how do we find f of 0?
By x plus h all squared.
Yes, so here we replace. Look here, this f of x equals this. Here x goes here, right? So also when we find f of this quantity, we simply take x plus h, right? All this number, we take at the second power, right? And we add the constant 3. If I ask you what is f of a, how do you find f of a? If I have to ask this, how do you find that, please? F of a. If a was a number, how can you find the image of a?
A squared plus 3.
Yes, very good, very basic. A squared plus 3, right? Good. Now we come here. So now f of x plus h is here we have x plus h, right? Power second power 2 right? Plus please, plus 3, right?
Plus 3.
Okay, plus 3. Now, minus, what is f of x? Same is x squared plus 3, right? Plus 3. And we divide by h. Right. Let us see what we'll obtain. Now we continue now with the calculation. Okay, this will be, as you can see, x plus h squared will be x squared. I hope you can all remember this. Plus, how do you find this? X plus h, second power is x squared plus 2.
2xh.
Xh, yes. H plus h squared, right? Clear. Plus 3 minus x squared, right? Minus 3. And we divide everything by h. Now I can say that we can simplify this x squared here and minus x squared, right? You see that? 3 minus 3. What will remain? Remain with 2xh plus h squared, right? Divided by h. We can simplify by h. What do you get when you simplify by h? H multiplied by, can you continue, please? Who can continue? H multiplied by
2x
plus
plus h.
Yes. Okay, plus h over h. Great. And here we can simplify again h, right? We end up with the quantity 2x plus h. Now, remember, we want now to take the limit when h. Now, when this number h is very small, what will be the limit number here? When this number is very small, now take the limit of 2. But here by limit, I mean, what will be the end of this calculation? If h is extremely, if h goes to 0, intuitively, what will we have?
2x.
Yes, exactly. When this h is 0, this will simply be equal to 2x. Full stop. 2x. This is our last answer. What do we then obtain? Then we now have that. So the derivative of the function now is given by the f prime of x equals then 2x. This is how we define the derivative of the function at the point x. What was the function again? So otherwise we have the following x power 2 plus 3, right? This function, if f of x equals x squared plus 2, then, right, then the derivative is equal to simply 2x. Right. I know it's still difficult to understand because
excuse me, sir.
Yes, please.
Can I perhaps just make a general comment?
Yes, please. Do.
I think I don't know if it's just myself, but if you write the function as x, you use the bracket x formation, but if you write the answers, you write it as an x that almost looks like a multiplication sign.
Oh no, it's the same thing. I'm sorry, it's the same thing.
Yeah,
It's
no,
only
no, I just
because-
wanted to, yeah, because that I got lost there for a moment.
Oh no, sorry, it's the same thing. The only problem is that because I'm typing with the mouse, it's very hard to write with the mouse.
Yeah,
But
no,
it's
I
not-
understand. I just wanted to make a general comment. Thanks. Sir.
Yes, please. Thanks so much. It's actually X here, like this. It's simply because, right, something like that. But it's simply it means X, right? Thank you so much. Now, so here we have our first function, x squared plus 3. Look here, please. And the derivative of this function is given by 2x. Right. Then, luckily enough, we don't need to apply the formula to obtain, or sorry, the definition to obtain the derivative of the functions. It will take too much time to do so. We have very good formulas that we'll use to obtain the derivative of nearly every function. But for now, that is how we define the quantity, the function that we call the derivative of the function. The first maybe some rules that we can maybe even do that now. Why not? Yes.
Sorry, sir.
Yes, please, no problem.
I just want to check here. You talked about h if is equals to 0.
Yes.
Meaning that you separate that, you will say 2x is equals to.
Yes. Here I have the limit. I'm here, right? I'm sure I'm here, right? Can you see the board, please? Yes. 2x plus h. When this when this number h, like if we take for instance, look here, 2x plus h, right? This here h is a number. Let me take for instance 2x plus. Give me any simple number of any simple number that you want. So take for instance 0.1, right? 0.1. Take another even smaller than that one. A number that you want, please give another number smaller than 0.1. Let's say 0. You can say 0.001, right? 2x plus something even smaller, right? Say 0. Something extremely small. 0.0000001. So the question is, what is the limit? At the end, what do we have? Right? At the end, what we add to 2x is absolutely significant. And at the limit, we end up simply with the number 2x. And to believe that's what we can obtain. So we have the limit. Say, how does this number vary if h becomes very, very small, right? We'll simply have this will simply come to nothing, right? And we simply remain with simply 2x, right? Does that make sense?
We'll see when we go forward.
No, definitely we won't come back. We won't come back here again, unfortunately. I mean, maybe fortunately.
Prof,
yes, please.
While we're still there, can I please ask a stupid question?
No problem.
So I wanted to find out.
Please feel free to ask any question. Any question.
Okay.
There's no question at all. Please, yes, please, no problem.
The limit. Is it always 0, or does it happen that the limit becomes another number?
The limit
What are the chances?
Yes, the limit can be another number. Well,
okay.
Let me. But of course, for the derivative, we consider the case where that difference is very small, right? I mean, here we have f of x plus even if they don't use delta x. Let me even leave h and simply use delta x, right? Like a difference or a change in the value of x minus f of x, right? and you divide by, here now we divide by what? Delta x. This here we divide by the difference. You can see that like the change in the value of f divided by the change in the value of x. This is like a delta y divided by delta x, right? Y depends on x. Now they say, okay, what will be this change? I mean, what will be the ratio rather when the change in x goes to 0, right? If this change is extremely small, what will, maybe I can even start with another example. Let me take the very first example here that we had. Let me take here, say x squared plus, maybe I'll convince you with this one, x squared plus 3. Sorry. I wish we had enough time to go in detail with the theory of limits. Plus 3, right? I repeated the same example, right? Let me consider, for example, the point 2 at 2. F of 2. What is f? What is f of 2 again? Now, in this example, f of 2 is 7, right? Clear, right? Are you with me, please?
F of
Yes.
2
Yes.
is
Good. Good, great. Let me take now f of 2 plus a small number. Say
Sorry,
2.
sir.
Yes, please. Yes.
You say f of 2 is 7.
Yes. 2
How
squared.
do you say?
2 power 2.
How do you
Right? 2, right? Power 2. Here we replace x by 2, right? 2 power 2 plus 3. Right? This is 7. See, 2 times 2 is 4 plus 3 is 7, right?
Yes.
Oh, good, okay. Now, let me take a small number like 2 plus 0.1. Let me change that one. Around 2. Let me take 2.1. What will be the answer, please? 2, say 2.1. What is the here? What is the answer here, please? 2.1.
7,41.
7,41. 41, right? 41, right? I believe you. I will. Please make sure it's correct, please. Okay. Let me even go much closer to 2. Let me take maybe 2, something like 0.001. What will be the answer, please? Try to find the answer there.
7.002.
7, please don't lie to me, please make sure it's correct. 7, 7, 0.
I get 7,004. Did you say 2.001?
No, yes, this one, yes.
Then it's 7.004.
For what, please? For something. Only 4.
7,004001.
Oh, good. Okay. Okay. Right. Now let's take the difference. Now, if we take this now, f of 2, 2.1, 2.1, right? Minus f of 2 divided by what difference here? What is the difference of the numbers divided by 0.1, right? The difference. Please follow me carefully. What is that? Let's find the answer. Here we have 7.41, 0.41, right? Divided by 0.1. What is the answer, please? I'm sure you have your calculator around. What is the answer?
Oh, 4,1.
Okay, 4,1. Yes, 4,1. Great. You see, it's close to 4, right? Now, next, let's take now the next value. So it's becoming very small. Up you can still see. Okay. Now let's now take the next a value which is closer to 2.001 minus f of 2, right? Please find the answer. Divided by 0.001. What is the answer here, please? Quickly, please. What is the answer there? And all the numbers are there. 7,00 point something. 001 divided by 0.001. What is the answer, please? Come on, are you lost?
Yes. No, we're still there.
Okay.
4,001.
Yes, 00.
Some of us are lost.
Okay, where are you? At which level? Here we have, look here, I have 2.1, right? 2.1, 2.001, right? Minus f of 2. 2 plus h, here I have f of 2 over h, right? So here I'm taking numbers that are very close to 2. Remember the formula, f, I'm sure you'll say this was the most difficult lecture ever, but actually we'll make it simpler. Please bear with me for a few more minutes. Here I have 2 plus h, look here, 2 plus h minus what, please? Minus f of 2, right? And we are dividing this by h. That's what we are doing. Here I take h very small, going to 0, and see what will be the limit, right? Now, what do you observe? Can you already make some kind of conclusion? For 2.1, here we are at 4.1, right? 2.001, the answer is 4.001. If we continue, what will be the limit? If I take f of 2, say, comma, another small number, 0.000, say 2, why only 1? It can be a number there, any small number, right? Minus f of also 2 divided by this. Here, divided by what?
H.
Well, what is h here? 0. Right? It will be 0.00. This small number here. How many zeros? 50. Right. Okay. What will be? Okay. What will be the answer there, please? Of course, it will be 4, something. Right.
Are we changing 2 with 0?
Yes.
All the time.
Yes. No. I mean, I'm not taking any small number. You can take your own small number, right?
Okay.
Any small number, nearly 0, right? That is what we mean by h here. So whatever we do here, the answer will always be, when we divide by this h, look, will be close to 4. Yeah. Do you agree? Please do the calculation if you want. You have here, 4. I'm answering a question asked by one of your colleagues there, right? So here we have a number which is very close to 4. Now you can see why at the limit, that's what we said about. Now, in general then, you can therefore see that if we take f of 2 plus h, right, minus f of 2 divided by h, right? And I take this number h very small. Very small. Limit h goes to 0. What is the answer? Intuitively, what will you obtain here? Here we have 4.1, right? Here we have 4.001. Here we have 4.0000 something, right? At the end, we'll have only 4, right? Then the derivative of this function f prime, now f prime of 2 at the point 2 here will be equal to 4. This is the derivative of this function at the point 2, as you can see, because we have that, look, f prime, we have already seen that f prime of x is 2x, right? 2x. Then, if I have f prime of 2, it will exactly be, to type with this mouse is terrible. Computer, I have a new one, is not yet ready to. Yes, f prime of 2 then will simply be equal to 4. 2 times 2 is 4. Well, to answer in short, the answer was that we have to take h going to 0. So we want to see a small variation in around x. What will be the consequence of that variation around the function? I mean, around f of x. Right. I'm sure this is still not very clear to you. How do we compute in general? How do we compute? This is the question that we have now to answer. Given the function f of x, right? How do we compute? How to compute? How to compute what, please? Who can you compute the question? How do you compute what? How do you compute what, please? Who can compute the question? How do you compute?
Sorry, sir.
Yes, please.
Sorry.
Yes. No problem.
Before that, I'm little bit lost. Maybe on you wrote something like f of x plus delta x.
Yes.
Minus f of x.
Yes.
All divided by delta x.
Yes.
Maybe if you can explain to us what informs to divide by that delta x.
Very good.
Is it the formula or what?
Yes, very good. Thank you. I will do that. I like the question. Excellent. You could see our trying to so my take off my jacket. So here we have the function. We have the function f of x, right? Let me take another example. Or give me your own example of a function, any function that you wish. Okay, let me give mine, right? If I can take 4, let me maybe take 4x power something, maybe power 3, right? I'll explain from this one. Great. Are you with me? What? Now, for sure, if we have x plus delta x, if the quantity x varies, say for instance the price, assume here for instance that x is the price of a commodity, right? X price. If there is a change in the price, right, by a quantity that I denote by delta x, what are this here, the x here what does this delta x mean here? Basically, assume the price of a commodity. Assume the price changes by the quantity delta x, right? X is the price and F, say, maybe the quantity, for instance, right? So you want to understand what will be the effect of that change in the price into the quantity, into the demand, for example, for instance. Now, let's take here f of x plus delta x minus f of x. What does this then mean? This is the new quantity, right? New quantity minus, this is the old quantity, right? Or the previous quantity. Are you following? Are you with me, please? What's the question I want to? I'm trying to answer you. What's the, sorry for the long for a long answer. Are you with me, please? So we have the function here f of x equals 4x power 3. Right. Yes, please.
Sorry, sir.
Yes.
We mean that this x is the quantity.
Yes. No. Here I take x as just a silly
as the quantity
example. Yes. X is the price. X here is the price. Right.
Then and then this delta.
Now, good. Now here f. Now this f here is the quantity. Right. Quantity.
Then now, that delta x and then this delta x
is the change in price, the variation in price, right? Like the price of petrol, the price has gone up. There is a small change, right? This is the change in the price, the variation in the price. Are you with me?
Yes.
Variation in price. Now we want to understand the effect of the variation in the price into the variation in the quantity, right? Variation in price and variation. Of course, if there's a variation in the price, you can expect a variation also in the quantity, right? But by how much? What is the rate of change in the quantity due to a change in the price, right? You see the variation or the change or difference, right, in the price. Thank you for asking me the question, right? Now, if this is the change in the price, then you can see that this will be the change in the quantity, right? Are you with me? If delta is the change, it means like change in price, right? Here. So this now, this difference, this is now the change in the quantity. Here we have the old quantity before the price goes up or goes down, right? And this is the quantity after the price has changed, right? Now we take the change in the quantity divided by the change, the change in, now is clear, divided by the change in the price, right? So here now we have all of this divided by delta x, right? Is now the ratio. Change in the quantity divided by change in the price. And now, of course, this will be the rate of change. But now when we take the limit, important, we now take this quantity, we now take this change or this ratio when this change is very small. Delta x is very small. This is what we mean by the derivative of the function with respect to the variable x. Right, so I take down that the change in the price, the change in the quantity divided by the change in the price when the change in the price goes to 0. Right. Does it make more sense now? Or you still have any further question, please? I don't mind answering any other question there. No question, no. Great. I'll take him out maybe now an example, but let me take, maybe this can help. P quantity equals, for linear model, even much easier. 3 or 30 plus 5p. P is the price, Q is the quantity. Right. If I ask you, what is the rate? What is the rate? The rate of change in P, or how does P change? Q change with respect to P? It's even much.
This is 3D or sorry, sir. This is 3P or
sorry, 30, please. 30, please. You are very funny.
Oh, thank
30,
you.
please. Come on. Sorry, it's 30. Yes, 30, right? Consider this quantity 30 plus 5p.
So it's 5.
Yes, 5. This is 5. That's 5. You are fine in this class. It's very funny. Thank you. This is 5. I wish I could write nicely with my pen. 5, right? 5p. Great. If I ask you, how does I mean a change? If I take delta Q, we even did this one day when we discussed the issue of elasticity. What is this change? Please give me the answer there.
5.
5, yes, very good. It's 5. It's true. The change in Q due to the change in P. If you take, for instance, one can even see how that is true. Take any value for Q, right? Or for P rather. Take P equals, for instance, 1. If P equals 1, what is Q? Please, quickly, please. 35.
35.
Right? Yes. Take another quantity. P equals 2. What is the answer?
Q is going to be 40.
Good. Now take it out the difference. The change in Q, what the change in Q will be the difference, right? Change in Q will be 5. Do you see it? And change in P. Okay, maybe to save
1.
1. Great. Let me do this to don't lose anyone. 40, right? Minus 35, right? Right. Divided by change in P now is 2 minus 1. And here we have the answer is 5. You see, this constant. This is the rate of change in Q due to P, right? 5. Great. If I change a little bit and put Q as follows, Q equals, yes, please. Yes.
Sorry, sir. Where do we get this 40?
Yes. Good. Thank you. P equals 2. Here 30 plus 5 times 2. You see here? 5p. This is 5 times p. And p is 2. So 5 times 2 will be 10. Right? 10 plus 30 is 40. This is Q equals for Q here. The new value of Q. So remember, I didn't put it here. Sorry. Right. So now the change in Q will be this difference, right? Change in P will be this difference, and change in P will be this one. Right? 40 minus 35, 2 minus 1. Right. Now, if I take another example and I assume, for instance, let me take, for instance, here, say 30 plus Let me see now. How can guess this one? 3q power 2. Sorry, p power 2. Sorry, p. Okay, please now give me the answer here now. If I take delta p, delta q over delta p, what will be that? First of all, why do you think this ratio is important? Delta q over delta p. Why do you think is important? Of course, every manager wants to understand how will a change in the price affect the change in the quantity, right? Because the quantity, the demand depends on the price, right? So it's important to understand how will any change in P affect the change in Q, right? What is the answer there? This is no longer obvious as before because it is now a nonlinear function, right? But if we consider this, the limit when this delta P, when the change in the price goes to 0, right? One can compute now and take this will be equal to the derivative of the function Q at the point with respect to the function P. Sorry, with respect to P, and we can find that this will be 6p actually, right? But we'll see that after we'll find out the formula to do that. We won't apply again the definition. We'll simply apply the formula. When we'll do that now on Wednesday. Please, any last question on this definition before we continue? I mean, before we look at before we close even. Summarizing then, if you have no question, let me say this. We then have here a function f of x. Unfortunately, we didn't even do a single example today, but we'll do next time on Wednesday. We are given a function f of the variable x, y equals f of x, right? Given. We are then asked to define a new function called the derivative of f, which is f prime of x. This function is very important, as you will see in this in the next chapter. The question is now, how do we compute f prime of x, and why is it important, and what can we do with that new function that we obtained from the function f? You see the derivative of f. Now we'll find out some rules, very elementary, very easy rules to apply. How to in order to compute the derivative of the function. Maybe I can give you the first one. We are done, please. Of course, we wasted some time because of the network. The first rule is the following: if the function is given by x power n, when n is a number, then the derivative of f is given by, what is this rule again, please? Can you remember this? F prime of x equals, okay, remember this rule. First rule, f of x equals x power n. What is f prime of x? I call it the power rule of the differentiation. What is f prime of x? Anyone, please? N x n minus 1. Okay, we'll continue on Wednesday. It's time. Yes, any questions that you want to ask, please, before we close? Wednesday, then I hope we're going to have any issue. Yes, please. Yes, Yolanda.
It's not a module related question, but maybe you could assist me.
That one must be very difficult to me, Yolanda, but I'll try. Yes, please.
Okay, thank you so much. I have been trying to reach the administration of the economics department. No, nobody responds to my emails since the 5th of August. I've been calling. No one responds to the calls. No, the calls can ring for ages. I even sent you an email. I'm sure if you check, I sent you an email asking for your assistance. And I also sent Molas an email. I do not know what to do now.
See what you can do, Yolanda. You can, if no one answers your calls, why don't you, you can drop an email to the secretary of the department.
If you could provide me with an email, I would be very grateful.
You send me. Did you send me an email?
Yes, I sent you a personal email.
I'll reply to it. Let me see. I'll reply to it and send you the name of the secretary of the department. I'll find it on the system. She will definitely.
Thank you very much, sir.
This is truly not fair that you send an email and no one since the 1st of August and no one.
Yes.
Really not fair.
And to make it worse, it concerns registration. They had told me they are working on it, and unfortunately, I can't be physically available at one of the campuses. So I'm relying on calls and emails.
You want to register for? You want to register for? Give me your student. Give me your student number. Did you? Maybe I'll see your email, right? You provide.
Okay. My student number is 16.
Okay, please, can you send to me an email? I can even try to walk there myself at the registration and ask what is the problem. It's not far from my house. I will try.
Thank you so much, sir. Thank you so much. I would really appreciate it. Thank you. Okay, let me send you another email right now.
Yes, please. But to tell me exactly what is the problem, and I'll go there. I'll walk to the registration and ask them what is the problem. Thank you, Yolanda. I'll try that. Or Wednesday, please. Yes, I see. Yvette, I see we have a question.
Hi, Prof. I just wanted to know, we've got three classes left with your online classes Wednesday next week, and then hopefully Wednesday this week, and then Monday and Wednesday next week, before assignment 2 will be due on the Friday. Do you think those 3 classes will be enough to get through the differentiation theory, or should we just go ahead on our own?
Definitely, I will try to cover it. Absolutely, we will have more than enough. Yes.
Okay.
Definitely, it will be enough.
Thank you. That's good news. Thank you.
Please go through. If you can work ahead, and if you identify any question, take a note, and you can bring it to us even on Wednesday. But I will try to go as quickly as possible to cover everything on this chapter. Thank you, Yvette. Thank you, everyone. Let's meet again. Please come early. Be there on time at 6 o'clock on Wednesday, that we can try to push and do as much as possible. Thanks so much. Enjoy the rest of the night.
Thank you so much, Prof.
Bye-bye.
Bye.
Yeah.